Huzzah! Hello. We're gonna make sure this other stuff works. We're gonna check stuff. I see the mic working. I see closed caption. All right, I'm looking at you, looking at me, looking back at you. All right, that works. Let's make sure the other microphone works. I am so on high alert for this thing. All right, let's just see here real quick. All right, so I'm gonna switch over to this guy. And I have audio. I have camera. Yep. Excellent. It works. I swear the next time I launch this, it wants to update and I don't want to do it. I want to do it. You can't make me do it because I'm going to look like this. I don't want to look like this. I want it to just work, okay? Because then I end up looking like this. So, like, why? Why does it have to be so angry? Hello, everyone. I may have gotten a little bit on OBS's case to check this stuff before I start doing stuff. But yeah, it's fine. Is okay. We got this. Fantastic. Hello, Mr. Man. Welcome on in. Oh, good lord. Do I have enough energy? Not really. I just have really good tea. That's what we have here, all right? You know what we got with that tea? We got some honey. And in that honey, we have some English tea bags. So it's a breakfast tea I'm drinking in the evening. Because we need to get through this because I'm about to lose a part of my mind. The last I left off with toying around with the Protogen, I needed to put together something to separate the regulator for the power. It's going to separate between the big battery pack and the rest. Now, for those of you who are with us that do not know what I'm talking about, let me switch scenes and show you what I mean. Okay. So, what I have with me here is the beginning of a battery pack, which then it's going to get filled with batteries, like such as this. I screwed up the design initially because the BMS that controls right here, the action. Thank you, Gamer, for the resub. Tis appreciated. How much we rocking here? We were talking 5 months. That's a lot of months. Hello, welcome on in. Yes. So this is the regulator. Listen to me talk with words. This is our battery management system, which this permanently needs to be connected to said battery, right? Which then batteries go on the bottom, batteries go on the top, and that puts us with 6 parallel 2 series. That's 12 batteries in total. So where I screwed up is the regulator, which is, you'll notice here, the wire actually managed to break off the board, which is a whole nother issue, but we're not worried about that right now. This cannot permanently be connected to this, because if I do, then it's just going to end up just draining the battery. So to fix our problem of these really weak sauce connections, we have these nice, I'm going to not quite want to use the word waterproof, but yeah, it'd be what it is. We have these guys. And I started off camera to model a little box that we could put the regulator in, which is that piece. And I screwed up real good. So we're going to try again tonight, and I'm going to show you how I got to the mistakes in that. Say hello to the first attempt at the little box. There are 2 little holes in the bottom for the wires to come out, 2 holes right there for the connectors, and then 2 holes in the back so that the other half of the harness could poke out. First problem, these aren't big enough. I don't know what I did, but I measured this wire with my caliper and I screwed up the dimension somewhere along the way, so the wires don't fit through the box. Next problem, this is my first time trying to cut a slot out of a 3-dimensionally designed object. Jack that up real good, because the slot is, it's tall enough, but it's not wide enough. So then if I take said object, no. The answer is no. It doesn't fit. It's not wide enough. So that's a problem. And then I also have my cool first time making via the instructions, which we're going to try again tonight on camera, to make a lid, which is cool. It's got a little bevel and it doesn't fit. So I'm not entirely sure what I did wrong to that. So we're just going to follow through with the directions again and see if I could suck less this time around. But the end goal is to look something slightly larger than this, because the other issue is this was supposed to fit in sideways or flat, and it doesn't. I screwed up. But I can explain how I screwed that up. Feel good. Yes, attempt number 1. And attempt number 1 equaled a bunch of suck, but that's okay, because that was the first attempt. No one ever gets it on the first attempt. And that includes me. There was no winning on the first attempt. So what I did is I modeled the piece with the I modeled the piece anticipating a wall thickness of 0. I never calculated for the fact that there's going to be thickness in the walls, because again, since it's a 3-dimensional space, I kind of need that or it's not a box. So I did math, just very poor math. Kind of leads into my favorite phrase of the risk I took was calculated, but boy, am I bad at math. This is a solid description of that. So tonight, we're going to spend some time in Fusion, and I'm going to take stab number 3 at this, because this is technically not the first attempt. This is technically the second attempt. The first attempt never even made it to the printer because I jacked up the model somewhere along the way, and it stopped letting me cut holes. I couldn't figure out what I did to it. So, yep, Proof can't do math. That is very much on brand. I do networking stuff. I am not a 3D designer, and we're talking about making a basic box with some holes in it. So I can't even add breathing holes to a box. Don't come to me in an emergency. I'm not gonna be able to pop a hole in it for you. We're gonna need better math. So what we're gonna do is I'm gonna fire up Fusion 360 for the first time on camera here, and we're gonna play. So without further ado, we're gonna jump into it. So from here forward, we're going to. I have my caliper, and I have the stuff that I designed poorly. So we're gonna figure this out. So first things first. I am now realizing I don't know if I have the scene fully set up the way I'm supposed to. We're gonna fingers crossed that. Okay. So I have microphone. I have some of the sound alerts. I forgot to check the scene. Okay, no, we're here. We have stuff. All right, great. So, what we have here now in our 3-dimensional space is the origin, which I could spin around. And what we're gonna do is we're gonna turn this metaphorical into something physical. Or at least so goes the theory. So, what we have over here in the upper corner is our origin on 3-dimensional space. So similar to like what happens with 3D printing, we're going to change the music because that's going a little hard. We've got 3-dimensional space, and then this gives us our top, right, left, bottom, all that fun stuff. And that allows us to spin the origin around. Let's get that back into frame. Whee! So we're going to select the bottom. And then we're going to create a sketch. Okay. So essentially the way Fusion works is that you give it different parameters for dimensions, and then you add volume, and then remove volume, and then boom, you have a thing. In this case, a fairly poorly put together thing. But that's okay, because we're gonna get it this time, I hope. Also, if anybody noticed my go live notification, may I forgot to update that before I click the go button, but you know, it's fine. Can't remember some of the things I was supposed to do. Okay, so save me. I didn't do anything yet. I literally can't save because there's nothing to save yet. I have to actually do a thing. That's okay. We'll get there. We'll get there. You're jumping the gun on me. All right, so we're gonna create a box, right? So first thing we're gonna do is we're going to make a rectangle with a center point. We're gonna base it off of the origin, and then we get to add some dimensions to the thing. So the entirety of what we're looking at is in millimeters. And I'm also gonna add myself some notes here off screen. So that I can you know, keep track of the goofy dimensions that I may have forgotten to fully include last time. So we know that our walls are going to be 3 millimeters thick, because I forgot about that last time. And we're going to want a box that requires some dimensions that probably should have taken the caliper out of the box. And I will show you what the caliper is, because I'm going to talk about this a bunch tonight, because I'm going to use this thing a bunch tonight in hopes of figuring myself out. So let me just show you guys briefly what I'm talking about when I'm talking about the caliper. So I need this little guy over here, and I'll move that out of the way. This is a digital caliper, and when I turn it on and I zero it out, I can move this open or close, and it gives you the measurement of here. This is an inner diameter measure, and on the back is the depth gauge. Now, we're only worried about getting measurements of the things that we're going to be looking to encase in plastic. So what I'm going to be doing off camera while I'm chatting with you guys is measuring these different pieces to get the different sizes of things. That's how I got close, but not all the way there on the first go around. Yeah, technically the second go around, but who's counting? I know I am. So that is what we are currently wandering around with. So, if I remember correctly, I'm gonna measure this thing. The regulator itself is 20 millimeter by 30. A perfect 20 by 30. Now obviously we need to make room for stuff and things to occur, like walls that are going to hold the box. So let's figure this out. Let's say that for the long side, if it's 30, we're going to have 3 millimeter walls. That puts us at 36 to just add the walls. And then let's add an extra 3 millimeters of play. So that'll give a little bit of wiggle room in the box. So let's make our first dimension 39. Why am I not clicking in the box? Oh, it's because I clicked out of context. That's fine. Let me just note that. So we'll do 39 millimeters. That'll be width. And then will be long, and then wide for 20. So then we add on our 6. That gets us to 26 to add the walls. And then 26. We'll do 29 for the other dimension. So we'll do 29 millimeter. And then height. Height, we need to have enough room to have the little board that's in my hand fit in the box, but also 2 of those little USB-C connectors. And then we have to obviously punch holes for the wires to come out of the harness. So let's figure a height of like 35. What did I do the first time around? What was this one? This one's 30. 30 was tall enough. All right, we'll do 30 high. The height was okay. Okay, so I'm gonna come back over to here. I'm gonna hit escape. No, I wanted to escape from that action, thank you. Then we're gonna go to rectangle, center rectangle, shove wop, and then we're gonna do 39 by 29. And we'll bring the camera in. Okay. Now we want to add depth. So we got to add the height now. So in Fusion, the way you add depth is E for extrude. And then we're going to make it 30 millimeter high. And if I rotate the camera slightly, you can now see that the box has depth. I hit enter to accept that, and now we have a cube. So that is the first part in making a three-dimensional object. Now the next thing we want to do is we want to carve out some space for our stuff. So I'm going to click on the top. And now the top, I'm looking at this definition over here so I can keep track of what side I'm on. And then I'm going to go over here to shell. And then we had agreed on 3 millimeters thick. So that then makes all of the walls 3 millimeters across. Now the next thing I could do to double check that I did not screw up this inner dimension, right? Because I carved it out, I feel pretty confident that I didn't screw that up, but I didn't check it. Well, there's a tape measure built in, so we're going to measure that. So we're going to measure from this line to this line and see that it's exactly 23 millimeters between the two. So if I take a look at my object, I put that back in my hand, and on the short side, my object is 20, 23 gives me a nice 3 millimeters of wiggle room. And then if I measure it from top to bottom, so we'll measure from this point I don't know why it's doing that. I want to go to measure and measure. I don't want angles. I want measure here to here. Exactly 33 on the dot. So then I'm going to check my measurement again. This object is exactly 30 millimeters, and that accommodates for our extra 3 of wiggle room. So that gives it a little bit of back and forth in the caliper, which is perfect. That's the dimension it should have been the first time I tried to put this together, but I didn't think that through. Now I have. All right, so we can close out the inspection tool, and then I'm going to save it. All right, now we've initially saved the first body. Now we're going to name the first body. So I'm going to right click on this. We're going to rename it. This is going to be the reg box for regulator. So then that also allows us to keep track of our pieces inside of the assembly. Because I'm going to tell you something right now. Once you start putting a lot of sketches together, it gets ugly. I can promise you that. I saved the first couple of attempts just, you know, as trophies. Because they're ugly. Okay, now we have our spinny box. We now need to do some stuff to it. So we need to carve out a total of 4 holes for the wires to go out the back and out the front. And then both slots that are going to make up the area where the USB-C ports go. Now, I think I figured this out from last time. I think. So we're going to do a sketch on this face. And then we're going to do some lines. We're going to run down some constructor lines. Banana. Banana? Did I miss the announcement? Is it full of potassium? Toast? You have lost me so hard. Banana toast? What? I got questions. I don't necessarily know if I want answers, but you know, it be what it is. Alright, good. Neither do I. It's fine. It's fine. Alright, put down some construction lines, which are the dotted ones, which don't do anything other than just giving you a point of reference. So I cut the box into fourths, just to give us a little bit of an idea. Let the intrusive thoughts win. Alright, that's fair. Now, I want one more construction line. And that other construction line is to give us a bottoming out on how high the regulator sits.
Can I get a glass of water?
Yes. Yes, you can. Thank you. Thank you, gamer, for the liquid. I am only mildly waterproof, so it'd be what it is. All right, so I'm gonna zero out my caliper, and then I'm gonna get an idea of how tall this thing is. Because what I don't want to do, I don't want to accidentally cut a hole that's too close to the top of the regulator inside the box, because it's going to live on the inside of the little box, and I don't want to cut the hole too low. So let's say a complete bottom out would be at 8 millimeters. So then we're going to do... Okay. So that right there is a nice indication we want to go no lower than that. If we go any lower than that, then we're going to crash into the board that's going to be sitting right down here. So that gives us an idea of where we don't want to go. And then we can actually just coordinate that off as a no-go zone. When I hear regulator, all I could think of is the cave diving gone wrong videos. Oh God, no, it's not that. It's not that kind of regulator. We don't want to look like this, okay? I mean, we could still end up looking like this if the regulator doesn't do its job. I don't want to really be a flammable proto, but that's besides the point. All right, so this is a no-go zone. So that's our center line. That's our don't go any lower line, and then we'll place our stuff above this line. So now that we got all that figured out, we're going to turn off construction. And now we're going to actually carve some holes into this thing. I also be mindful that I don't go slightly too tall. So, yeah, we'll be all right. So we're going to take another stab at this, and I think I might have known what I screwed up. So I tried to do a slot, because a slot perfectly represents the shape of the USB-C port. But I did bad things. So we're gonna see if we get it this time. Protogen coming out of fire resistant fur. What's the next? Not waterproof. Okay, now hold on, Thunder. I already expressed this in great detail. Is the fact that the batteries are gonna go into something that I can quick release from myself. In case I screw up somewhere along the way, I would like to keep my pants not in flames. That's what we doing, okay? That's a part of the plan. I already did all the safety stuff, and for those of you who don't know, I got myself a lithium encapsulating fire extinguisher that's sitting within 3 feet to my left. I am, if nothing, serious about the safety of this bullshit. It's real. Also, hi Flux, welcome on in. So yes, we are doing the thing. We're doing the safety thing. But right now, we're just trying to not to screw up another design. All right, so create we're gonna try this again. I struggled with this so damn bad. All right, center point arc slot. I got just the right slot. This is where I think I really screwed myself. So a center point slot. Create a linear slot defined by a center point, located of slot arc centers and by slot width. Specifically the slot center and place center of a slot arc. Click to specify slot width or enter a diameter of the slot. Oh god, we're gonna have a bad time. Gotta keep warm somehow. Call it what you will. I'm keeping my eyebrows drawn on. That's the gig. All right, we're gonna play around with a couple of these as I try to figure myself out. Howdy alls, welcome future cheater. Cheetah. Welcome, future Cheetah. How are you doing in this lovely time zone that you've found ourselves overlapping in? I'm over here losing my mind playing with three-dimensional software. And no, it's not the usual ones. This is Fusion. Oh god. All right, so that's the middle of the box, right? So if we figure, if I just go right above the middle of the box, that'll probably work. All right. Now here's where I think I screwed up last time. Why Fusion? Because it's the one I've somehow managed to get enough of an understanding. I really couldn't grasp Blender all that much, and I didn't look into FreeCAD, but that kind of ended up where I'm at. Got today and tomorrow off work for this tooth extraction. Oh, that's right. You're doing the thing. We're doing the wisdom tooth thing where the teeth are not very wise. Oh god. Lots of water holes. Lots of water. Well, Flux, you're going to be welcome. You're going to be well within good company because you're going to watch how poorly this goes for me. Good lord. Safety for the undead. Call it what you will. Flux, I think your boyfriend's probably onto something because Blunder's the one that a lot of people get really good at, and something tells me you'd probably be just fine. Alright, I wonder if this width is supposed to be half of the slot, not the whole slot. Because if I give it the whole slot value, that's going to put me at 13.6. And then... Yep, I was right. It's supposed to be a half value. Because there ain't no way that that's right. Will Blender blend? That's a good question. I don't actually know. You know Blender, you did it once. Yeah, no, that's fair. Sketchfab too. You know, I've heard mixed things about Sketchfab, but I haven't tried it myself. It's not Autodesk Inventor, so all right, that's fair. You know, I also for a while there spent time in Wings 3D, which is another open source one, and that's actually how I first got into my space of 3D design. Was trying to learn that not complete product. And dear God, was that educational? I did get some useful stuff out of it, but yeah, no, it's friendly is not quite the word I'd be looking for. You're mixing metric and imperial like NASA? No, none of all this is in millimeter. Nothing here is in empirical. It better not be, or I'm gonna start crying. Alright, so this should then be 8 for this first value. And then for the slot height, we're looking at 5 point... like 5.8. Alright, so now let me repeat that again, and then we'll move them around, and then we'll start cutting stuff. So we'll do that one more time before those measurements leave my head. We're doing a slot, center point slot. We're doing 8 by 5.8. Okay, good. All right, I can't have that leave my head, or bad things will happen. Oh, and ads. That's okay. We'll wait until Ols comes back, and then I'll save my pieces to what we're up to here. All right, I don't want that close to the top, so we're actually going to move this down. I'll move this one down. Welcome back, Ols. To answer your question, we're working on putting together a little box to house the regulator for the Protogen project. Because I screwed up and the regulator can't be physically connected to the battery all the time or it will drain the battery. So this is going to be a little box to house those parts. I somehow managed to define those lines and won't let me move it anymore. There we go. Yes, so we were playing around in Fusion 360 trying to put together a little box. Ooh, you did it, Ding! What'd you do? What'd you do? I want to hear. I want to hear the good stuff. I also have to be able to carve out the other 2 holes for the other stuff, so I probably shouldn't go too low. You know what? Let's actually just tie... Yeah, that's what I did. I tied it to the origin. And then... We'll leave that little bit of a gap, so then there should be more than enough engagement here for the lid. And then we can work to carve out the holes here and here. Now, I mentioned that the middle of the regulator stands kind of tall, but that's in the center. So we should still be able to carve out our lines over here for the other stuff. Ooh, All's coming in with a 3 stream streak. All's, there's a redeem. There's a redeem called streak. Go play with it. It's fun. That was the last thing I put together. I completely forgot to mention that on last stream that I finally put together that redeem. Bruh. Come on, stream elements. Don't be shit on me now. Yeah. Okay, now does anybody know what that little dinosaur is from? I'm gonna imagine you do, but I want to know if you recognize the wide eyes, if nothing else. The Google game. So it is in fact the little guy from Google Chrome when you don't have internet. But fun fact, if you disable the game via policy, which is known as the Easter egg game, and you tap the space bar to play the game, it just instantly kills him. His eyes go really wide and he gets hit with asteroids. So yeah, unfortunately that became the redeem. I saw that when it got disabled via policy and I'm like, what? Oh my word. He didn't deserve that. He was just minding his own business. Okay, now here's where things get to be a little painful in Fusion, and I'm not terribly good at this part, so we're going to try our best. If a line is blue, that means it's not defined inside of Fusion via its dimension in relationship to the object. So if the line's blue, that means that we probably can proceed forward, but it's not fully defined, which means the sketch won't fully lock when we exit it, which is what hurt me last time. So we're going to play with this a little bit and see if I can convince the lines to stop being blue before we proceed forward. Now, a part of how that works is by doing the dimension with the D key, and you're going to probably witness why I usually have such a bad time with this. So let's define between here and here. Okay, so that gets those. Now we just need to figure out how to define the sides of the slot. Oh, opportunity to finish off your school reports. Oh no. There's something wrong about being a teacher and then being stuck with homework. Because we all hated homework growing up as kids. And then you went, what about second homework? Like you straight up went full-blown Hobbit mode on education. It's not quite second breakfast, but it's definitely very much something to remember. And I'm not sorry that you're now going to think of the Lord of the Rings every time you're grading papers. I don't know if I'm a bad influence, but I'm definitely one that'll make you think of weird stuff. That much I can confirm. Alright, if we just define this to here. That's all you have to do. Okay, let's go. Define the other line. Oh wait, hold on. There we go. Yes. Okay, so something that's a serious pain in the ass with this program is that if you accidentally try to define more than the same dimension more than once per, I guess, feature is what this would be referred to as on the object, which is the overall thing we're working on. It throws an error called overconstraint, and it does bad stuff because then it prevents the sketch from finishing out. Now, I can escape to make that disappear. Now, as you'll notice, the very first sketch that we use to make up the bottom, which is highlighted, has a lock next to it, which means that the sketch is completed in full. The one we're on right now that we're not done with still shows the pencil. Since these are fully defined and they turned white, I think that means we're okay to continue. I hope. Normally they turn black, but the fact that we define them and they all turn white, I think that means we're going to be okay. I don't know the program terribly well. I just know enough to be dangerous. So we continue. In the middle of school, I had 5 teachers who were all LOTR nerds who played Dungeons and Dragons. Ah, yes. I don't set homework. I don't want the stress of grading. And when I'm mentally checked out, yeah, that's fair. But you still got to deal with it, which is kind of annoying. All right, so can I have to finish the sketch. Do these still allow me to move them around? Oh, see, they're locked, so I can't move them around. So yeah, the pencil didn't change. Well, it still allows me to pull the push-pull menu, which is exactly what I needed. Because now we're going to carve out some additional holes. And the way we're going to do that is instead of 2 distance, we're going to do 2 object. We're going to choose the back wall because we're cutting backwards, and that cuts out the first slot. And now we're then going to go back into the sketch. There we go. Because it hides it, and then do the same thing to the other one. All right, now we have the beginning of 2 slots. They're going to make up our box, which is great. And those actually look a little bit more realistic to the shape of the object I have in my hand. So fingers crossed I don't screw that up further. I think this is going to get us pretty close, though. We've got 4 more holes to carve out and to make a lid. Put your hand on the lid. The lid. The lid. Put your hand on the lid. I am a SpongeBob fan, if you couldn't tell. That is one aspect of life that's never going away, and I love it. Thank you. I will do the thing. Excellent. The lid. The lid. The lid. Stop, freeze. Getting warmer, warmer, colder, warmer. Blazing! You're on fire! It burns! There is something wrong with me. I don't care. All right, let's see here. We got that, and then holes. We need more holes. All right, I need the harness because I don't know what the hell I did. I need wire. All right, bring this back over here. We're gonna make some more measurements. Hopefully better ones this time. I hope. Yeah, I'm starting to wonder if I measured the wrong ones because I do have technically 2 different widths of wire here. It's fine. All right, so let me also try something that may or may not go according to plan, but you know, it'll be what it is. Yeah, see, that sketch didn't lock after I exited it, which means that there's still something with those slots that aren't fully defined. And since the lines went white, not black, that's probably why. But to be honest, I don't know. Normally, if you can move parts around of a item that you anchored to the sketch, then that means that's something that's not defined. And the program is smart enough most of the time to be able to interpret what you're trying to do, even if you don't tell it exactly what you want, like an anchor definition. I still don't fully understand the program. Like I said, I know enough to be dangerous. So we're going to just keep kicking the can forward and hoping for the best. Now, the other thing that I know with our little situation here with the holes is that the wires come off the top of the regulator board and then exit. So I still want the holes for the wires to be near the edges of the box. So that's going to be the first gecko. Now I also want to make sure that I leave enough height for it to actually clear the top of the box, or excuse me, to clear the top of the board and be able to be bent enough to go out of the box. So let's figure that we put the holes at like, or if I can get away with 12 millimeter, or if that'll overlap with the slot here. We're about to find out because we're going to make a new sketch. Yeah, so we're going to bring this down, and then we're going to throw a constructor line on here to give us an idea of if we have that amount of real estate. Not really. 12 millimeters would put us right here, which would end up carving out part of the slot. So that's too tall. So what if we were to go with, instead of 12, what if we do something like 6 for the center of the hole? That should at least allow us to offset it a bit. And then we also have to accommodate for the fact that this wall is 3 millimeters thick. So then let's figure that's the full thickness of the box. We got to keep going. So what if we put it maybe at like 6? No, like 6 by 6, so we just punch a hole right through the center over here. I think that'll still allow the wire to like come over and out. Alright, so then let's go with a center dimensional shabam. Now let's figure out a hole that'll actually be wide enough to fit the wire. So I'm going to zero this out again. I'm going to grab the thickest of the wire I have here and see that. Actually, let me measure the hole of the first failed attempt to see how wide this is. .8 millimeter, which means this was probably supposed to be 3, and the printer just shrank the holes a little bit because they're kind of small. Yeah, 3.2. Check the other side here. 2.7. 2.8. Yeah, so that was definitely supposed to be 3, which obviously was way too tight. So let's accommodate for some shrinkage on this. And yeah, because even measuring this is like comfortably 3.3. I definitely used the wrong dimension on this. Let's go 4.5. I think 4.5 will be all right. That'll accommodate for a little bit of shrinkage. Whoops! I used the wrong kind of line. That was not supposed to be construction. Take 2. Turn off construction. Draw a hole. Au revoir. 4.5. Here we go. Okay. So we got that. And then we're going to do the same set of lines for the other side, and then we'll see if we can anchor it in a way to make it not pissy. So we're going to do construction. And then we're going to do 6. I said construction. There we go. And then we're going to do another line of the construction variety. That's 6. And then we're going to do the circle at 4.5. All right, now we're going to use the dimension doohickey. Then we're going to define some stuff. So yeah, that was the warning I was worried about. Over constrain the sketch, so we can't do that. So maybe I'm supposed to select. Oh, all right. So the arc is what it wants me to define. Sure. No, can't do that. So I could define that and it's fine. Yeah, but the lines still don't want to change colors. That's the thing that gets me. I don't quite understand what else it would want me to define. Because if I got a white line, that I would have thought would have been enough. But it doesn't seem to be the case. Now what we're going to try to do is we're going to try to cut through both sets of walls so I don't have to repeat these steps on the back. Because we do need 4 holes in total. Positive and negative per side. And go the distance. So I'm going to hit you. I'm going to hit you. E for extrude. To object back wall. Yeah, look at that. That's gonna let us carve it right out in one shot. Nice. Would you look at that? We got some nice holes carved out of that. So we got 2 slots, 4 little holes, and dream. Now we're gonna save again, and we're going to work on the lid. Now, before we work on the lid, we also have to add a little bit of smoothness to the box, because we don't want it super rigid, because 3D printers don't tend to like super rigid. I'm gonna see if I can get this right this time. So first things first, we're gonna add a little bit of curves to our box. So we're gonna pull up the curvy menu. Should be the perfect time for us to appear in here. Like we're doing what? Not those kind of curves, Hedgie. Not those kind of curves. Shoot, I was gonna shut him out. I can't remember his is it a set 34? Guys, do you remember offhand what Hedgie's full handle is on the platform? Because it's escaping me. He used to be a set Peepo and then he renamed himself. I don't recall. Oh no, I'm a bad friend. I don't remember his new tag. All right, so we got some rounded bits, which do look a little nicer now. And then, so in the tutorial, they rounded out with a bit of an inset on this, which I think it screwed up this. I thought it was a set 13, I think. Which I guess I technically could try it. Nope, doesn't exist. Shoot. Ugh. Wait, I'm dumb. I'm being dumb. Am I being dumb? I could be being dumb. Maybe. Try the Lord Gamer. No, not by the way I'm sharing my screen. I can't do that. That's alright. It's okay. I'm shouting him out in spirit. He's a good little Hedgie. He does fantastic artwork. I will find his handle. He will get a shout out here in a little while. once I generate the lid. Alright, so now what we're going to do is we're going to stop losing hand tracking for the love of Pete. And we're going to go to bodies. I'm going to make another component. Insert the active design into an assembly design as an external component. Select an assembly design to insert into, then uses the manipulators to the canvas or initial positioning dialog to place components in the target design. I think I may have chosen the wrong option to start this as. So normally I would make a separate component and make the lid, which... Alright, hang on. Let's see here. We're gonna look at me for a minute while I try to figure this out here, because I think if I choose add to assembly, this design needs to be saved first. Save and insert. Add to a new or existing assembly, new assembly. insert components. Okay, all right, cool. So that one. All right, so yeah, all I did was then just insert. Yeah, I told it to insert it into a design. And then from here, I can then do. Right, so then we'll do insert component. We're going to put it inside of Regulator version 3, which is the one we're working on. All right, so that's creating a new thing in the tree. Reference to other components will be captured in the assembly reference. You can toggle associated from the edits. Okay. I think that's fine. So let's finish that in place. Oh boy. This is where I got lost last time. All right, so here, so let's kill that. I don't want that. All right, so then we have this one that I want to edit in place. Go to bodies. And I want to make a new component. New body? Can I make a new body? I want to create a form. Find window. Select the component to insert and use them in the manipulate and adjust this position. Alright, and I already technically did that with this. But we're going to construct based on an offset plane. So we're going to go based off of XY plane. And this is where we wrote down the height of our box. So our offset is going to be 30 millimeter high, which is cool because that then gives us the ability to create a thing floating over in space. It's not physically attached to anything, but that's okay because that gives us the ability to play. And now from here, we're going to create a new sketch on nothing. Do a center rectangle, and then we're going to make a lid. And we were playing with 30 before, but that's okay. This doesn't have to be an exact science here. We do want a little bit of room. So figure something like 42 over 28. 13, 32. I might if there's a little bit of overhang. That should be all right. And then we're gonna use the trick of extrude. Or it won't. This is what happened to me off camera. Bad things have happened. It's not letting me extrude. I wonder if it's because it's not physically attached. Yeah, see, it's not a separate body. That's the problem. Yeah, I can't extrude it. 1 food and 2 coffee. Much excellence. So, I did bad things. And the question is, can I do it? Way to save myself. All right, what if we were to kill that sketch? I wonder if I have to go into the main. Oh, I see what I did. I didn't create a separate component. It would be a circular reference, but it's all part of the same suite. So, like, Hmm. Alright, let me see what we're doing here. To the internet. Create a new body within a new component. I click the top level of the parent to browse the tree, new component, name it, and activate it. Oh, I see what I did. I wasn't supposed to do that. All right. Boop. Boop. New component. Yes. Yes, that's what it's supposed to do. All right, good. So I love that if you create a new component at the top tree instead of at the component tree, that it does something completely different and not what you want. Oh, it's fine. It's fine. The program doesn't hurt. I promise. It's like, I know what I want to do, but I have to tell the computer what that is. Good lord. All right. As we can continue, we're going to try this again now. Construct off plane, plane offset. Holding left click. Holding left click again. XY. Selection not found in cached body or sketch. Oh, for the love of Pete, why? Construct. Is that because I don't... Oh, you are active. Construct. Off plane. You know, for someone who just selected the correct plane, it's a little funny that you think it's not actually there. Well, that's cute. Wonder what it's doing that for. Selection not found in cached body or sketch. Is it because I have to have the other layer selected, question mark? I mean, I suppose that's technically possible. If I re-highlight the upper layer, go to construct, offset plane, XY. Okay, so that exists. So now let's switch back to the lid. Edit in places unavailable. Why? Use edit in place, change the design status to editable. Ugh. Wait, does that mean... I think I know what that means. All right, hold up. So let's go back to... All right, so I think I have the wrong origin turned on. So let's hide that origin. Turn on that origin. Cries in technology. Offset plane. XY. Okay. Wait, that's a part of... Right idea. Hold up. I have this have... That's selected. Yes. Because you're tied to that. You should have turned gray. Hmm. Show all bodies, remove visibility. Right, because finishing the edit, going down to here. That origin is showing, but I'm showing the origin of supposedly the new body, I hope. Oh, I called it a lid. Alright, let's try this again. Construct, offset plane. Oh, back into the same hole I fell into before. Lovely. Oh, there we go. Turn around so I can actually see it. No. May I, higher power, have mercy on me. Good lord. Alright, so we've got an error. It won't let me create the offset plane. And this is beginning to make less and less sense as to why. That's exciting. So... this is why we check if we delete too much stuff. Alright, so... Right, now my issue is I don't want that plane there. Because I want it to be a part of the lid. So let's go to the assembly, let's create a new component. Yeah, see, it creates a separate tree. Okay, so separate tree, and now the item looks the way that it did before. So now I'm going to turn on your origin, go to construct, go to offset plane, rotate our semi-transparent object, XY, and it fails. XY, and it fails. If I'm selecting that origin, why should it matter? Okay, what if we do an offset plane? Let's just select this face, and it's already 3 millimeters above. If I just add in 30. Okay, sure. That's not the way I did it in the tutorial, but I don't know if it really matters. The fact that the object is semi-transparent does at least tell us that it's creating it as a separate object because it grayed out the first component we made, which is the box. So now we're going to create a sketch. That is going to be our lid, hopefully. Center point rectangle. So we'll do like 40 over... Yeah, like 32 should be okay. There we go. I can open up the push pull menu. Excellent. Add some thickness. Okay, so now we have a lid. And the lid is not connected to anything, and there's also no inside of the lid, which we need to work on next. So we're gonna do a little filletness to make the lid match the rest of the body design. Yeah, that works. Take some of the corners off. Alright, and now this is where things got a little funky with the tutorial that I followed along with last time. So we're going to end up using the point of reference from the inside of the box that's semi-transparent. We're then going to add depth, we're going to attach it to the lid and combine the two. And then we're going to see about hopefully formatting that in a way that it'll actually fit this time. I don't know if I selected the wrong faces last time. Or excuse me, inner walls, I mean. So hopefully we'll get it right this time. That's the theory. I hope. That is the sheer hope. All right, so for me to do that, we're going to turn off the lid, which will make it disappear for a moment. And then we're going to use this really cool thing that I found where I'm going to click P to select a plane or face. Or apparently I'm going to forget how I did this. Or am I going to forget how I did this? All right, hang on, tutorial time. I know it wasn't even that far into the tutorial, but that's okay. So I'm going to go here, and this is why I saved the resources, because it's all about selecting the outer lines the correct way and then making it happen. So I'm going to go here and go back a screen, and I'm going to go to my notes, and then I'm going to pull up the video, and I'm going to get whacked with ads because we love ads. Who doesn't love ads? Ads for days. I'm looking at ads about stopping data centers, and you know what, I feel that.
Bob, can I get a glass of water?
I like that idea. Thank you. All right, so we do know how to. We know how to lid method. Yes. All right, so I have selected the plane, which is fine. So we do that. We add some thickness. We did that already. Instead of ads, just hydrate. Indeed, indeed. Alright, so then we deflate the box a little bit, which we did, which is fine. Oh, that's what I forgot to do. Okay, I gotta turn the origin back on. Okay, so I made a boo-boo. That's okay. I just have to hit escape, and then we're gonna go back to our constructors and turn back on that plane. We need this plane again. So we're gonna do a new sketch, and then when we click the P on the keyboard, that gives us the project menu. I knew I'd find it. Okay, so now that we have the project menu up, we're going to project some action on these interlines. So we're going to select all of these. Say OK, which will turn it purple. We'll then hit E for the push-pull menu. Now, this is going to do two things for us. We have the lid that we can't see right now, that's directly floating right above the plane that we're working on, but then we want to add some depth down so that the lid goes into the box to give it something to grab onto. So instead of a positive number, we're going to work with a negative value here to go down. This is the part that I mentioned that I wanted to be careful that we didn't cut these slots out too close to the top, because if we did, the lid won't fit. So if we do, say, -4 down, that puts us, I think, probably a little closer than I want to go. Maybe it does, maybe it doesn't. And then I have to turn the lid back on so we can see that. And that actually shows you, there we go, I had to turn the lid on to see that. And the action is a joining operation, so we can see that right there. So that's joining the lid to this insert that's going down. And I think we'll do maybe -3.5. There we go. So that'll leave us a little bit of an operating gap for the back of the jack to go into the box and then the lid to come down. Now we're not done yet, because there's a couple more things we need to do to the lid in hopes of getting it to fit in the box this time. There's this thing called the taper angle, which is what's going to allow us to fillet the lid insert inwards, that will allow the lid to fit a little bit smoother into the structure. So we're going to have a taper angle of -7. Maybe we'll go -10. Might be a little too much. About 8. So then now the lid goes in the whole way, right? But there's that notch it makes. Now I did 7 before, and that seemed like it wasn't enough. So let's play with 8 degrees of freedom. The nice thing is that if for some reason the lid still doesn't fit, you can go back in, you can modify these numbers. The biggest part is making sure that you don't break the design in a way that you can't figure out where to go. As you can see, that structure, it's a mess. I just wanted to create a thing underneath the body where I had the box and call it a lid. And what did it do? It broke out this big menu, which I'm sure means something to someone somewhere, but that is not here. And now we have our lid. If I hide box, that's what it looks like. Now, I have a little bit more I want to do to this. The transition is really hard between the insert and the rest here. So we're actually going to add a fillet to these lines. So we're going to add a fillet there. We're going to work our way around the box. And then we're going to go -0.5. It's not going to let me do that. Why is it not letting me do that? Yinks, look away! Look away, this is all shit, you don't want to be here. How you doing, buddy? The joys of parametric design. Your model going poof if you mess up one of the linked parameters. You are so correct. Yinks is the smartest cheetah I know in the 3-dimensional space. I know enough to be dangerous. That's about as far as I could throw myself in this particular item. Alright, so if it was just -0.5 last time, I think that's what I wanted to do. Yes, because it gives us this nice rolling structure all the way down the lid. And then to save a smidge on plastic, I'm going to also do a little fillet on the inside too. I'll shave off a couple of grams, nothing major. Luckily, my company uses a non-parametric CAD program. Well, that's mighty fine. Okay, roll ball that in. So we got a nice, neat plug to plop on top of the box, which is right there. So now if I do finish edit in place, save our changes so we don't lose anything. It then gives us a lid as one body, and then the box, which is the other body, which allows us to take those two objects, separate them, and 3D print them. So now, I didn't think this far ahead. Let me see if I can present that part. So I'm going to convert these to a mesh. It's just right click on the object, save as mesh, nothing special there. I will leave all the defaults, click OK. I'll give it a name so I know what on earth I'm looking for. Do the same thing to the lid. Save as a mesh. Save the settings. And then I'm going to minimize that application. Now, for any of you who spend time with 3D printing will know the program known as your slicer. Different programs come preloaded with the printers out of the box. Some of them come with a link. I use the one called Cura that I use to splice my objects for my printer, which I use a Creality Ender SV something 3. I don't know. It's the auto leveling one that they have, and it's actually a pretty decent printer. So what the slicer does is it's going to take our mesh that we just spent the better half of an hour and a half playing with, and turn it into some machine code that the printer can understand. Anytime you make something in 3D space, this is the piece of software that gets it the rest of the way to the printer. Because say you have a piece of an object that is too big to fit on the print bed. Well, the slicer is capable of breaking that bigger object up into smaller pieces that you can then join together later to make the big thing. That's something that a lot of people don't know about 3D printers. Just because you have a printer with a bed of 200 millimeter by 200 millimeter by usually 200 millimeter, usually it's a perfect square or perfect cube, I mean, doesn't mean you're limited to just that size. You just have to break the larger object into smaller ones. Thankfully, we don't have to deal with that tonight. We just have to throw the objects on the bed and profit. So let me see here now about pulling up a copy of that. Okay, so I'm going to bring our camera in here. And we can see right here, those are our two big notches right there. We've got our 4 holes for there and there. Now you're going to notice a couple of things here that this program does. Blue is contact with the build plate. Red is an overhang, which means that if it's not supported and it's not touching, then you're basically, think of squeezing a tube of toothpaste over your sink. It's going to get everywhere. There's no support. Hence, the application wants to add support. Now, I don't want to add support under the lid because it's not oriented in a way that makes sense to print. I don't need supports on the lid. I need to spin this object around so that the biggest, flattest part is the other way. So we're going to click on that. We're going to rotate this. And just like that, no more red, because the lid is fully committed to being printable in a shape that isn't going to cause trouble. Now, the little box is going to be a little bit of a little bit more of a complicated conversation, because no matter how we orient this, there are going to be holes that are going to require some kind of support. Now, we can get a little clever about this. Right, because we can still reorient this in a way that we won't really need supports. Right, so if we rotate this way, that's going to support all of this, and then there's some carved out edges because we rounded it, right? that will need support, right? And then this back wall would have nothing, right? So if we look at it that way, that would require a bunch of infill in the center if we go that route. Now, we could see what this looks like though with infill, right? So if I slice it and give it a minute to generate and then turn on the preview, we could see right here that this light blue is the, not brim, skirt. This is the skirt that's going to, or actually no, it is a brim because it goes all the way around. A skirt goes around it. A brim touches the edge of the 3D printing object. And we can see here that to give this inside of the box support for something to print onto, it's going to add a bunch of this plastic in the center. Now, if I pull this down layer by layer, we can see here that it's just a bunch of lines to fill in that gap, so that once we finally get to this part right here where we close this edge of the box, then it has support to print all of this face. And then the holes for this side aren't really much of a concern. Now, I can tell you, doing it this way is a bit of a pain, because removing this large chunk of 3D printed plastic is a bit of a nightmare. So I'm going to go back to prepare and see what else we could potentially do with this. So if we leave it oriented that way, that is going to be a bunch of infill if we do that, right? Now, if we spin you back around to the way I initially had you, and we slice it and look at the preview, so it's going to look to add a little bit of infill to fill the holes here, and then it's going to want to touch on this inside. Now, I can tell you right now from experience, this amount of infill is a serious pain in the butt to deal with, just because of the fact of how tight to the base of the object it is. So when you're 3D printing, you kind of have to choose your battles on what you deal with and how much you want to really deal with post-processing after the fact. Because looking at this isn't too bad. It leaves the majority of the center of the box open, and it's just a small amount of infill here that you just knock out with like a flathead screwdriver or a razor knife if you're going to be careful about it. And then we can see over here in the corner the amount of time it will take. It will take an hour and a half. It will use 24 grams of plastic, or also 8.21 meters of filament. So that gives you that amount of filament it's going to take in two different metrics. Because if you had an idea of how much was left on the roll in length, well, then there it is. But if you don't know, well, you can just weigh your roll by taking the whole roll, putting it on something, and then noting how heavy the roll itself is without any filament on it. Most filaments have printed how heavy the roll itself is, so that you could subtract that from the amount of filament that's spooled onto the roll. And with this, I think this is probably going to be a pretty decent attempt for us to try. Now, I'm not too terribly concerned about the lid not just falling off for two reasons. One, the fit's probably going to be pretty tight, so I don't really anticipate it going anywhere. And two, I plan on putting either a small piece of shrink wrap over the top of the box and leaving the holes and wires exposed so that we can plug stuff in and out, or I might just use some like a thick rubber band essentially to hold the top of the lid shut. Nothing really over the top, but again, this is a first prototype on something that's a really large project, so I don't really want to overthink this part. I just want it to get it far enough along that I can get it to work, and then I can make improvements later. Because this is one of those areas that I'm sure that I'm probably going to want to try and make it better. And that, we'll see. Oh, you never worked with 3D printed parts. I can see the issues only having one machining direction. Yeah, exactly. Yeah, or tape. Tape's totally valid. So is glue, or silicone is actually another good one too, because silicone you can at least pull the parts apart. It does stink though. It's got a pretty nasty heavy odor to it. Okay, yeah, that sounds mighty fine. Flux, you go enjoy the foods. Mighty fine. and we'll catch you next time. So yeah, with that, we have got our file that we're going to 3D print. So this then is going to meander its way over to the printer. And that pretty much concludes the toying around for this evening. So I'm going to save up all my stuff. We're going to print this, and then I'll add updates in the Discord of how things look after they're done. Hopefully everything fits. To which then do a little soldering work. Thank you. It's appreciated. The slice is fine. I have to actually finish converting that, which is just saved the disk and choosing somewhere for it to go. I got it. I promise. Yeah. Yeah, double triple save. Exactly. Well, hey, this is like our third attempt at trying to get this right, so I'm feeling pretty confident about this one. Yeah. So with that, let me see who's floating around.